So students, what we want to discuss today, that is about extrinsic semiconductors. किसके बारे में बात कर रहे हैं? Extrinsic semiconductors. Extrinsic semiconductors क्या हैं और क्यों इनकी जरूरत पड़ी? We have already discussed about intrinsic semiconductor. उसमें जो कंडक्टिविटी की वैल्यू है दैट इज वेरी लो एंड द रीजन इज दैट द चार्ज कैरियर्स आर electrons and holes which are produced due to breaking of covalent bonds. So now if we want to increase electrical conductivity, then we have to add impurity. So now we will see here what type of impurity is to be added. So सबसे पहली बात, extrinsic semiconductor is also known as doped semiconductor. Now, what is the meaning of doping? Doping is the phenomenon of addition of impurity. Phenomenon of addition of impurity. किस में करनी है impurity add? To a pure semiconductor. Pure semiconductor में किस लिए करनी है? To increase electrical conductivity. Now the question is, what type of impurity? किस तरह की impurity add up होगी? Now, type of impurity which is to be added. So here, impurity of fifth group element. Fifth group element means where there will be 5 electrons in the outermost orbit, like phosphorus, or you are taking antimony. And the other is third group element, like arsenic. So these are the two impurities which are to be added to pure semiconductor. And due to the two type of impurity, here the semiconductors produced will be of the two type. When we will add fifth group element, then this is N type. And when we add third group element, then it is P type semiconductor. So now we will discuss in detail about these N type and P type semiconductors. Now first we see what is the meaning of N type semiconductor. N type semiconductor. So when we talk about N type semiconductor, it means that we have to add impurity of fifth group element like antimony. इसका बेटा यू मीनिंग हो गया, जैसे हमारे पास ये सारा intrinsic semiconductor है. Intrinsic means there are 4 electrons in the outermost orbit. ठीक है ना, ये कोर ऑफ द एटम हो गया और ये 4 बाहर जो हैं वो आपके पास आ गए. This is also fourth group, and let us say one of the is replaced by the fifth group. So here there are the 5 electrons. Again on this side the layer, it is 3-dimensional arrangement जो इसमें आपके पास है. So it will be like this. ठीक है ना, कि इस तरीके से ये सिलिकॉन के इसमें है, and only we have add up one to be of the antimony. सो इसमें जो इम्प्योरिटी एडअप होती है दैट इज इन द रेशियो ऑफ 1 in 10⁻⁶. दैट मीन्स कि 10⁻⁶ एटम्स के पीछे हम एक एटम इम्प्योरिटी का एडअप कर देते हैं. नाउ वी विल सी व्हाट विल हैपन ड्यू टू एडिशन ऑफ दिस इम्प्योरिटी एटम. ये देखो, ये कोवेलेंट बॉन्ड्स बन गए. दैट मीन्स कि 4 of the electrons of antimony will form covalent bonds with the 4 neighboring silicon atoms. So then even after that this electron will be free. तो इसका मीनिंग क्या हो गया? इसका मीनिंग ये हो गया कि addition of one impurity atom leads to what? Addition of one free electron. अब आप कहोगे कि कितने की इससे कंडक्टिविटी बढ़ जाएगी. बच्चे, मैंने आपको नो डाउट ये बोला है कि वी आर एडिंग ओनली वन एटम आफ्टर 10⁻⁶ atoms of silicon. But mind one thing, कि concentration is like this 10⁻10 atoms per centimeter cube. तो आप इमेजिन कर सकते हो कि कितने फ्री इलेक्ट्रॉन्स इसमें प्रोड्यूस हो जाएंगे. अब इसके बाद हम इसमें ये कहते हैं कि नाउ एट रूम टेम्परेचर ड्यू टू थर्मल एनर्जी फ्यू ऑफ कोवेलेंट बॉन्ड्स मे ब्रेक. हो सकता है थर्मल एनर्जी पे ये कोवेलेंट बॉन्ड ब्रेक कर जाए या जो यहाँ पर कोवेलेंट बॉन्ड है ये ब्रेक कर जाए. Now what will happen when covalent bond will break? Then electron hole pair is generated, as we have already discussed in intrinsic semiconductor. So इसका मीनिंग क्या हो गया कि इसमें ज्यादा जो चार्ज कैरियर्स हैं वो क्या होंगे? फ्री इलेक्ट्रॉन्स. क्योंकि एक तो जितने इम्प्योरिटी एटम्स एडअप किए उतने फ्री इलेक्ट्रॉन हो गए, उसके अलावा जितने होल्स प्रोड्यूस हो रही हैं उतने हो गए. सो दैट मीन्स इन दिस केस वी विल से इट लाइक दिस, दैट इन दिस केस फ्री इलेक्ट्रॉन्स आर मेजॉरिटी चार्ज कैरियर्स. क्या है ये बेटा? मेजॉरिटी चार्ज कैरियर्स जो मेन है. एंड होल्स जो इसमें है वो क्या है? माइनॉरिटी चार्ज कैरियर्स. That means in this case concentration of free electron is very very large as compared to concentration of holes. ठीक होगी बात? And now the question is why we call it as n-type semiconductor. तो यहां से देखो बेटा कि इसमें जो मेन चार्ज कैरियर्स हैं, मेजॉरिटी चार्ज कैरियर्स हैं, क्या है? फ्री इलेक्ट्रॉन्स. और इलेक्ट्रॉन के ऊपर कौन सा चार्ज है? नेगेटिव. सो क्योंकि इसमें मेजॉरिटी चार्ज कैरियर्स आर नेगेटिवली चार्ज्ड, so this is the reason that it is known as n-type semiconductor. So mind one thing in this case, के concentration of impurity atoms, और इसमें जो impurity हम एडअप कर रहे हैं that is known as donor impurity because it is donating electron. Addition of one impurity atom means addition of one free electron. So this is the reason that this fifth group element is known as donor impurity atom. So donor impurity की जो concentration है that is approximately equal to the concentration of free electrons. So this is how we can explain crystal structure of n-type semiconductor. अब एक question, one question in my mind, that is, here in this case we are saying that the charge carriers are negatively charged free electrons. But now my next question is that what type of charge is present ऑन एन टाइप सेमीकंडक्टर। एन टाइप सेमीकंडक्टर के ऊपर कौन सा चार्ज है? तो योर आंसर विल बी it is electrically neutral. N-type semiconductor itself is electrically neutral because you are replacing one silicon atom with one antimony atom. तो आपको पता है ना बेटा, atom itself is electrically neutral. So इसलिए हमेशा ये याद रखिए कि charge carriers are negatively charged in case of n-type. बट अगर आपसे पूछा जाए चार्ज ऑन एन टाइप सेमीकंडक्टर इटसेल्फ, तो वो क्या आएगा? वो चार्ज आपके पास नेगेटिव ही, सॉरी, वो एन टाइप सेमीकंडक्टर के ऊपर जो चार्ज है वो नहीं होगा कोई भी, दैट विल बी इलेक्ट्रिकली न्यूट्रल. नाउ वी वांट टू एक्सप्लेन दिस ऑन एनर्जी बैंड डायग्राम. दिस इज, ये क्या है? वैलेंसी बैंड. दिस इज कंडक्शन बैंड as in case of intrinsic semiconductor, and this is a forbidden energy gap. Okay, now you see in this case addition of impurity atoms are causing addition of free electrons inside the crystal. So now here we say that these free electrons will form discrete energy level. Discrete energy level means energy level with definite energy. So this is donor level, donor energy level, and here free electrons are present. कौन से फ्री इलेक्ट्रॉन्स? जो कि इम्प्योरिटी एटम्स की एडिशन की वजह से सेटअप हुए. तो हम इसमें क्या कह रहे हैं बेटा कि तो इंट्रिंसिक सेमीकंडक्टर की वजह से वैलेंसी बैंड और कंडक्शन बैंड हो गया. उसके बाद हम ये कह रहे हैं इसमें कि फ्री इलेक्ट्रॉन्स will be present in the donor energy level, discrete energy level, which is just below conduction band in the forbidden energy gap region. ये donor level कहाँ है? Forbidden energy gap region में, just below conduction band. This energy difference is very, very small. Now at room temperature, due to this thermal energy, these free electrons can move very easily to the conduction band. ये इलेक्ट्रॉन जंप करके कंडक्शन बैंड में पहुंच गए. And you know that free electrons in conduction band can move, है ना? अब इसके बाद हम ये कहते हैं, it may happen that one free electron from valency band jump to the conduction band, and when one electron will jump from valency band, then hole will be set up in this case. If one electron from here, then hole is set up here. So इसलिए इसमें क्या हो गया? Large number of free electrons are available in the conduction band to flow, and very few number of holes are present in the valency band to flow. So again, concentration of free electrons is very, very large as compared to holes. So we call electrons as majority charge carriers, holes as minority charge carriers. So this is energy band diagram of n-type semiconductor. Now we will discuss about p-type semiconductor. P-type semiconductor is formed when third group element is added. So इसमें हमें जो impurity add up करनी है वो third group element की करनी है. P-type semiconductor. So in this case, let us say this is intrinsic semiconductor silicon के साथ. It's like this. Here is again. Now here one is the third group element. So in the third group element there will be 3 electrons instead of 4. So it will be like this. So now what will happen in this case? Now you see, एक कोवेलेंट बॉन्ड यहाँ बन गया, एक यहाँ बन गया, एक यहाँ बन गया, लेकिन ये क्या हो गया? Incomplete. So that means here there is deficiency of one free electron. If we want that this octet should complete, this is possible only when one more free electron will be available. Now it may happen that let us say this electron jump to here to complete this octet. So what will happen here? Now here will be the vacancy. So that means in this case you can say it like this. The addition of one impurity atom will cause formation of one hole. यही बनाना इसमें. And again in this case we are saying that we are adding impurity to very small extent. Similarly, after 10 raised power 6 atoms, only one atom of impurity of third group element is added. So now here, this impurity is deficient of one electron, or you can say it can accept one more electron. यहाँ पर जैसे मैंने आपको बताया कि there are 3 electrons in the outermost orbit. So in order to complete its octet, it can accept one electron. So इसलिए this impurity is known as acceptor impurity atom. So addition of one acceptor impurity atom means addition of one hole. So in this case, concentration of the impurity atoms added means impurity atoms added per centimeter cube will be equal to the concentration of holes. I have written approximately because due to breaking of covalent bond, very few number of electron hole pairs may be generated. So 2-3 होल्स का नंबर ज्यादा हो सकता है acceptor impurity atom से, इसलिए मैंने almost लिखा है. So that means due to breaking of covalent bond, very few number of electron hole pairs are generated. It means that in this case, concentration of holes will be very large as compared to that of free electrons. So in this case, holes are considered to be majority charge carriers, whereas free electrons are considered to be minority charge carriers. So इसमें मेन करंट का फ्लो किस वजह से है? होल्स की वजह से है. And we have already discussed that how holes can move inside the crystal. They can move, vacancy can move from one place to another in the direction opposite to the flow of free electrons. And this hole is vacancy created by free electron. It means it is positive charge carrier. So क्योंकि इसमें majority charge carriers are holes which are positively charged, so this is the reason that it is known as p-type semiconductor. And again, what will be the charge on the p-type semiconductor itself? So our answer will be It is electrically neutral. No charges on the p-type semiconductor. चार में जो चार्ज कैरियर्स आर देयर, लेकिन अगर आप पी टाइप सेमीकंडक्टर की बात करोगे वो तो भाई इलेक्ट्रिकली न्यूट्रल है, बिकॉज उसमें आप क्या कर रहे हो, सिलिकॉन एटम फोर्थ ग्रुप एलिमेंट, एटम इज रिप्लेस्ड बाय थर्ड ग्रुप एटम, एटम is electrically neutral. Now we want to take this on energy band diagram. Again, firstly, valency band and conduction band, as in the case of intrinsic semiconductor with this forbidden energy gap. Now in this case we say that holes will be present at this very acceptor level. तो इसमें क्या है, acceptor level is discrete energy level just above valency band in the forbidden energy gap region. यानी कि due to addition of impurity, the holes are available in p-type semiconductor. Those holes will form discrete energy level known as acceptor level just above valency band. Now mind one thing, whenever you talk about conductivity, it is due to flow of holes in valency band and free electrons in conduction band. Now what will happen? Now electrons present in this valency band can jump very easily to this acceptor level. क्योंकि ये जो energy difference है, this is let us say of the order of 0.03 electron volt, and this energy is available as thermal energy. So electrons को जब vacancy नजर आ रही है तो obviously they will jump from valency band to this acceptor energy level to fill this valency. Okay, and now when electron will jump from valency band, hole will be created. So like this, holes are set up in the valency band, which will be responsible for the conductivity. Now it may happen that one electron jump from here to here to the conduction band, and due to that hole will be here. So majority charge carriers are holes and very few number of free electrons are present in conduction band. So इस तरीके से you should know that what is the need of extrinsic or the doped semiconductor, and how we can produce it, and then what is the meaning of n-type or p-type semiconductor. Now अब आपने दोनों पढ़ लिए, intrinsic भी और extrinsic भी. Now we want to differentiate the two, intrinsic and extrinsic. तो फर्स्ट डिफरेंस तो बड़ा क्लियर है. Intrinsic means pure semiconductor which will be fourth group element like silicon or germanium. Extrinsic means impure or doped semiconductors, so which will be obtained by adding impurity. Now second, in the case of intrinsic semiconductor, concentration of electrons is equal to concentration of holes. क्योंकि इसमें जो charge carriers हैं, those are due to breaking of covalent bond, so the number of electrons or holes will be same. But in the case of extrinsic semiconductor, either there will be concentration of electrons to be more or that of holes to be more. Both are not equal. Third, electrical conductivity in the case of intrinsic semiconductor is low, very low. ये नहीं हम इसमें कहेंगे इट इज हाई, इसमें बहुत कम है कंपैरेटिवली. क्योंकि देखो बेटा, अगर कंडक्टिविटी हम कह देते हैं हाई है, तो अब तो ये क्या बन जाएगा, कंपैरेटिवली हाई. बिकॉज अगर बहुत हाई है तब तो कंडक्टर बन जाएगा. लेकिन कहने का मीनिंग है कि हियर इन दिस केस ऑफ इंट्रिंसिक electrical conductivity is very low, and comparative we have to increase that, so that will be more in the case of extrinsic. Here in the case of intrinsic, conductivity is function of temperature. Now what is the meaning of this? कि मैंने क्या कहा, conductivity is function of temperature. That means with change of temperature, electrical conductivity will change. Yes. In case of intrinsic semiconductor, if you will increase temperature, it means there will be increase in thermal energy. That means more covalent bond can break. So electrical conductivity will increase. But here in case of extrinsic semiconductor, conductivity is function of temperature and doping. किस पे डिपेंड कर रही है बेटा, वो टेम्परेचर पे तो करेगी ही करेगी, उसके साथ साथ डिपेंड कर रही है डोपिंग के ऊपर. हाउ मेनी इम्प्योरिटी एटम्स आर added to it. So इस तरीके से हमने इंट्रिंसिक और एक्सट्रिंसिक सेमीकंडक्टर्स के बीच में डिफरेंशिएट कर लिया कि what is the difference between the two. Now similarly you can differentiate between n-type and p-type semiconductor कि दोनों के बीच में क्या डिफरेंस है, n-type and p-type. Now n-type semiconductor is formed with the addition of impurity of fifth group element, and here there will be the addition of impurity of third group element. In this case, in n-type, majority charge carriers are free electrons. The majority charge carriers are free electrons, and in case of p-type, majority charge carriers are holes. In case of n-type, concentration of electrons is very large as compared to holes. In p-type, concentration of holes is very large as compared to free electrons. In case of n-type, impurity is the donor impurity. In case of p-type, impurity is acceptor impurity. In case of n-type, this impurity, जो free electrons है, they will form discrete energy level just below conduction band. Here the impurity atoms, they will form discrete energy level known as acceptor level just above valency band. तो इस तरीके से we can distinguish between n-type, p-type, between intrinsic and extrinsic. I hope कि आपको पूरी क्लैरिटी इन सभी चीज़ों के बारे में, इंट्रिंसिक, एक्सट्रिंसिक, देयर चार्ज, कैरियर्स, क्लियर हो गया है. सो थैंक यू वेरी मच.